All right, so now we're going to talk about metamorphic rocks. Metamorphic rocks form when another rock is changed by heat and or pressure, meaning only heat, only pressure, or both heat and pressure. This rock picture, this shiny, really beautiful rock, is a metamorphic rock. The changes that occur can include the creation of new minerals and something called foliation. So we'll talk about what foliation is in a second. You can see in the rock that's pictured those shiny platy mica crystals. Those mica is that flat mineral that often looks really shiny and metallic even though it's not. Those minerals were created in the process of pressure on the rock. So they were actually not there before the pressure, and now they are. Here's another example of a garnet metamorphic rock where those crystals were created. I covered this. Changes occur in the solid state without melting. If it melts, it becomes an igneous rock. So there's our garnet metamorphic rock again. Sometimes this process is called recrystallization, which is just another way to say that the rock was changed because of heat and or pressure. Metamorphism can happen in different ways. There's regional metamorphism, which happens in a wide area. For example, when mountains are formed. So continent collision, where two continent plates are hitting each other, smashing into each other. All of the rocks in the entire area are metamorphosed. You may remember this picture. So you can see the intense pressure that would be created on the rocks in the area in the middle. You can even see the rocks in the mountain. Some of them are so hot that they've melted, but most of them are just sort of bent and folded up. Those are metamorphic rocks. Metamorphism can also happen by contact metamorphism, which happens when rocks come into contact with something really hot, like lava, and the lava burns or cooks just the edges of the rock that it touches, but nothing else. So they can have either foliated or non-foliated texture. So a rock might start out something like this. The atoms in it, the minerals in it are sort of aligned randomly. It gets put under directed pressure from the top and bottom. You can see the arrows, and it will become something like this. Not just denser and sort of more compact, but that the actual minerals inside of it will line up in the same direction. That is called foliation. So foliated metamorphic rocks show mineral alignment. And these rocks, the minerals line up parallel to each other. And this happens because the rock was under a lot of pressure at some point. So you'll see the actual minerals lined up. There's an extreme version of this called banding, where the minerals line up by density. And because density and color match up in minerals, the light and dark colored minerals alternate. So they form sort of striping, and that striping is called banding. It's an extreme version of foliation. Non-foliated metamorphic rocks, like the one pictured here, are composed of minerals that are not aligned. So this is a picture of marble. So here we go. We have our foliation over here. Oh, this chart is from page 7 of the reference tables. Feel free to pause and get your reference tables if you'd like. This chart is on the bottom of the page underneath the sedimentary rock identification table. So textures all the way on the left. We see foliation broken into two categories, mineral alignment and banding. That's the extreme version. And then at the bottom, non-foliated metamorphic rocks. And there's a few examples of each. You can see the type of metamorphism here. We just went over. There's regional and contact metamorphism, both listed. And then again, as a reminder, the map symbol is just used to represent the rock on the map. It's not a picture of the rock. So they're usually harder and denser than other types of rocks due to the intense heat and pressure that they're exposed to. So we often use that banding or foliation as a way to identify them. So this is an incredibly extreme version of that banding, the striping and the bent That's called distortion, and when the rocks are distorted like that, it's a sure sign that they're a metamorphic rock. So it's often used as a way to identify them. It gives them a striped appearance. And hopefully you realize that that word on the slide is misspelled. Sorry about that. Striped is with one P. The thicker the bands, the more intense the heat and pressure conditions were to create the rock. So you can see that on the chart. It gives a description, it gives the rock name and then a description under comments. So low-grade metamorphism. And then foliations forms what's called pholitic sheen, microscopic mica crystals. And then schist has platy, big chunky mica crystals. That's the rock we saw at the very beginning. And then finally, gneiss, high-grade metamorphism. The mineral types are segregated into bands. So banding means stripes. You can see that this is all formed by regional metamorphism when the rocks in the entire area are metamorphosed, intense heat and pressure. And you can see that the arrow points in the direction of increasing metamorphism. So it goes from low grade at the top to high grade at the bottom. So which rock experienced the greatest pressure? You guessed gneiss. You're correct. By the way, that is pronounced nice. The G is silent. It's mad nice rock. So how pressure changes a rock. A rock might start out looking something like this. This is a shale, which is a type of sedimentary rock. If it experienced low-grade metamorphism, those minerals would line up a little bit. If it experienced high-grade metamorphism, you might see some visible mica crystals, what they're calling schistosity in this picture, which is sort of a great word, but you won't need to know it on the regions. And then finally, the gneissic banding, the banding of the visible, dark, and light bands alternating. Another picture showing increasing pressure and temperature and how the rock would change from a shale to a slate to a schist to a gneiss to possibly a migmatite if it was under enough pressure. So there are also non-foliated metamorphic rocks. They're way less interesting, though, arguably more well known. They're at the bottom here. The one that you've definitely heard of is marble. And what's important about these is what rock they transformed from. So a marble was the metamorphism of limestone or dolostone, and they all have sort of a whatever it was before and whatever it is now sort of example. The other one, and they can form by regional and or contact metamorphism. So we're going to go into more detail with this when we study Earth history and we talk about the differences between those two types of things and how rocks get changed in the story of their experience. Hornfels is a metamorphic rock that always forms from contact metamorphism. It's the only one that always forms from contact metamorphism, or it's the only one listed in the reference tables. So another picture, cool picture of metamorphic rock. This has been our summary of metamorphic rocks.